All right, here we go. So first thing we're gonna do is talk about our positive. So I'm gonna do my positive angle in blue. Is that cool?
Yeah.
All right, so degrees is what we're used to, right? So degrees is our normal terms of rotation. So here we start at 0 degrees. Yes?
The flat line is 0 degrees.
The positive x-axis is where 0 degrees lies. Got it? Guys. All right. Going back to geometry. When you see this, what does that mean?
90 degrees.
90 degrees. So on our positive y-axis, this is 90 degrees. Okay? Now, each time I'm going now, each angle is going to turn how much? 90 degrees. So what's going to be next?
180.
180. After 180.
Oh, 270.
270. After 270. 360. We come full circle, right? Those are our quadrantal angles in degree and positive rotation. Okay? Now I'm going to switch to blue and talk about it in negative rotation. So negative means that we're going clockwise around our coordinate plane. Okay? So now I'm starting at 0 degrees. This is going to be negative 90 degrees. This is going to be negative 180 degrees. This is going to be negative 270 degrees. And this is going to be negative 360 degrees. Okay, so positive, counterclockwise. Do we see it?
Yep.
Negative, clockwise. All right. Now, you've been practicing converting from degrees to radians, correct?
Yep.
Okay, we're going to do the same thing here. We're going to find the radian values of our quadrantal angles. Is that cool?
That's cool.
All right, so here we go. Well, what's the radian of 0 degrees? 0, good job. Okay, what about 90 degrees? What is the radian value of 90 degrees?
-270.
Radian value. So
1/2.
there we go, good job. So it would be pi over 2. Does that make sense? It's a half times pi. We have 90 over 180. Do we need to see it?
Nope.
It's 90 times pi over 180. And what happens? What's 9 over 18? 1/2. Okay. All right, here we're at 180 degrees. What is 180 degrees as a radian? 1 pi. Yes, we're good. All right, what is 270 degrees as a pi in radians? Huh?
1 and 1/2.
So how do I write that as a fraction?
1 pi. No, 1 pi 2. 4 over 2. 3 pi over 2.
3 pi over 2.
What?
Okay. And now I'm coming full circle. So what is 360 in radian? 2 pi. Okay. Do we see our positive radians? Yes? All right. Now we're going to write in our negatives. So we have 0. Now we have negative pi over 2. Negative pi. Negative 3 pi over 2. And negative 2 pi. Okay, so the blue, that's our positive angle, our positive angles, right? The red represents our negatives, which just means that we rotated a different direction. Yes? Okay, every angle has a positive and a negative of it. Yes? Got it? Just like all numbers. Questions so far about the quadrantal angles? All right, so we're going to use these to sketch or determine where things are. So if I have 120 degrees and I wanted to create a sketch of it, what quadrant is 120 degrees going to fall in? What quadrant? Do we remember our quadrants? Let's talk about it. This is 1. This is 2. This is 3. This is 4. Okay? 2. Remember, your quadrants go counterclockwise as well. 1, 2, 3, 4. Okay? So 120 degrees is in what quadrant? 2. So we know that we're in quadrant 2. So we have 90 and we have 180. Where is it falling between 90 and 180?
Closer to 1.
120?
Yeah, like half of it. No, that's closer to 90.
It would be closer to 90. 120 would be closer to 90.
Yep.
So this is my angle. Boom. 120 degrees. That's my estimation. It's going to be closer to 90 because 120 is 30 degrees from 90 versus 60 degrees from 180. Yes?
Yeah.
Okay, let's do a negative. So negative 45 degrees is going to fall in what quadrant?
4.
Quadrant 4. Good job. So in quadrant 4, I'm here. Is it going to fall closer to 0 or negative 90?
Negative. It's right here.
It's smack dab in the middle. Why is it smack?
In the middle. Smack dab.
Smack dab in the middle because it's half of 90. So here's my initial side and here's my terminal. And this is 45 degrees. Okay, I'll draw my arrow. The arrow of your angle tells you which way you are rotating. How do you feel? Was that terrible?
Yeah.
Terrible, I know. All right, let's do it with radians. This is where it gets tricky for you guys because you are so afraid of fractions. Why would you convert it? Let's let the fraction be our friend. Okay, we have 5 pi over 4. 5 pi over 4. Where does that fall?
5 pi over 4.
What? Quadrant 3. Good job.
Wow.
Okay, if you have $5 and you share it with 4 people, how much is each person getting?
1.25.
1.25. Isn't that less than a half?
Ooh.
That's less than 1.5, which is 3 over 2, right? So what quadrant am I in? 3. Okay, a lot of times with fractions, think about it in terms of money. If I'm sharing my money, how much am I getting? Okay, which you guys can seem to work with. So, all right, so am I closer to pi or 3 pi over 2 at 5 pi over 4? I'm close to the middle. So my terminal side is here, right? My initial side starts at the positive, so it's going like this.
So would it be 3 closer to 3 pi over 2?
Or 1.25?
Yeah.
Yeah. It'll be closer to 3 pi over 2. Well, yeah.
Smack down in the middle.
All right. And then last, negative 3 pi over 2. Negative 3 pi over 2.
1.
Is it even in a quadrant?
No.
No. Where's negative 3 pi over 2?
It might need to be 8.
It's here. It's on our positive y-axis. Do we see that?
Yeah.
Okay. It's a quadrantal angle, so it lies on an axis, not a quadrant. Does that make sense? So our negative 3 pi over 2 is here. Okay. The difference is because it's negative, instead of us going clockwise, counterclockwise to it, we're going clockwise. We're going this way. That's the angle. So this is negative 3 pi over 2. The direction of your angle on the coordinate plane determines whether it is negative or positive. All right. Okay. So after doing what we just did, I want you at your table to go through and determine what quadrants would you draw these following angles in. Okay. So you're gonna put a 1, a 2, a 3, or a 4 in the box. Okay.
You got this, right, Terrence?
All right, we're gonna quickly finish 6.1. We were almost done on Friday. However, we just have a little bit more to go. So reiterating 6.1, we stopped at quadrantal angles. And with quadrantal angles, we talked about those are your angles that lie on your X and Y axes. Okay, so we we talked about how when you are identifying quadrants, it is counterclockwise from 1 to 4. 1, 2, 3, 4. And a positive angle, you go counterclockwise. So that's our blue values. Okay. Negative angles, you're going to go counterclockwise, and those are our red angles. Okay. So these are our angles in degree, and these are our angles in radian. Okay. We then talked about being able to understand where they're located and what they are. Ultimately, guys, you're going to have your unit circle memorized, especially if you're going into calculus. You're going to have all of these angles and all of these angles in degrees and radians both memorized. Okay. I don't know what I said. Radians and degrees. Okay. I'm running on limited sleep today, especially. I was doing well and things just downfall. So that's why we're doing it in pieces. So we're starting off with our quadrantal angles. So hopefully you're okay identifying where 0, 90, 180, and 270 are. Okay. They're pretty easy to identify, and hopefully you're like, oh yeah, got it. All right. All right. A little tip for your radians. Think of it in terms of money. Okay. Like a whole amount. So if you're thinking about it in terms of money, you have $1, you have $0, 50 cents, $1, $1.50, $2. Okay. I don't know if that helps you at all, but think about it in terms of money. Okay. $0, 50 cents, $1, $1.50, $2. Just
this like our like what is it called? Like wow, what is that?
no. This no. It's I don't know if it's a formula or more of a where things are. It's a guide. It's where things are located. Like these aren't going to ever move. Yeah. Yeah. Go. Yeah, they should be up there on where the assignments are. I've yet to put anything in the file cabinet. Don't know why I didn't open it. I will look in a second, but they were both up there. So there was a stack of notes and a stack of assignments. As of this morning. Phone away, Ethan. All right, here we go. So on here, we should have 2. All right, so we're looking at 5 pi over 4, okay? First thing we want to identify is what quadrant should 5 pi over 4 fall in? Okay, and why do you say 3? Look at that. So we're here at 1 pi. Here is at 1.5, right? See it? You get it? The money? Okay. So if I'm looking for 5 pi over 4, that's going to be smack dab in the middle. Okay. This is our terminal side. Our initial side starts at 0. So this is how you draw the angle. So this is 5 pi over 4. Yes, it's showing you which direction you're traveling. Which arrow? On the terminal or on the arrow?
Does that be an arrow?
This one doesn't necessarily need an arrow. This one, yes. Showing direction.
Okay, that does.
Okay. All right, let's try another one. Okay, this time we have negative 3 pi over 2. Where's negative 3 pi over 2?
2.
No, it's on the positive y-axis.
What are we talking about?
Negative 3 pi over 2 is on the positive y-axis. Okay, because it's negative, that means at my initial, instead of going counter, I am going clockwise. Okay. Yes? No? Maybe so? Willow, please put your phone away.
Oh, wow, I have the wrong.
You have your phone? Oh. My bad, homie. Everything in this room is my Kool-Aid. I stirred it. There. No. Some of y'all are sour and ruin it. All right. Okay. All right. Let's flip it over. So we're gonna do a check of navigating around. So pretend you see nothing. You saw nothing. You saw nothing. All right. I'm gonna give you 3 minutes. 3 minutes to identify what quadrants the following angles fall in. Okay. So you have 3 minutes to tell me 1, 2, 3, or 4, or X, Y axis. I will be printing more. Apparently they're all gone.
What? That's all. What?
I said I heard you. I couldn't do anything about it. All right.
Oh, just good.
Let's go. All right, in class unisons, ready? 7 pi over 3, mid 12. Where is it?
3, 4.
I said
The door.
2, 2, 2. Did we say 2?
Yeah.
All right. Okay, again, think about it. For radians, 0, a half, a whole, 3 halves. That's just 3 halves.
So you
And then-
ignore the pi.
Mhm.
Okay.
Look at the fraction. Look at the fraction value, okay? All right. B, negative 3 pi over 4. Good job. Negative 235. We got a 2, we got a 2. Good job. 5 pi over 3.
1.
4.
Oh.
Okay. So look, if you're in question it, 5 pi over 3, it's less than 2, but more than 1.5, right?
Yeah.
So therefore it's in 4. Does that make sense?
Oh.
If you have $5 and divided by 3 people, each person is like $1.33. And that's gonna be between what and what? Did I write 4? But $1.67. I did bad math right there. 7 pi over 6. All right, say it again. 3.
Oh.
285.
4.
I thought you were talking about when I said.
Negative 16.
4.
Good. Negative 7 pi over 4.
3. No, 2.
Okay, we got a 2.
Oh, it's, yeah. What ain't 3? Negative.
It's negative.
B is negative.
What does that do anything? That means they switched. They're going the other way. Try and look at the pattern. Negative 180 pi.
X.
It's on the negative x
Negative
axis.
X.
3 pi over 2. On the what? The negative y axis.
Oh, so you just put negative in.
Oh.
Okay.
All right. Yes. Okay. So that's all the knowledge you need to complete your 6.1 assignment. All right. We will have a quiz over 6.1 on Wednesday. So as you're going through this, if you have questions or you're concerned, you need to make time to get those questions answered. Got it? I said Thursday? Wednesday. Wednesday. Why are we saying Thursday?
We won't be here.
Oh, okay. It's like I thought I said Wednesday. You're making me think I was crazy. Okay.
You were a little bit sometimes.